Okay, so hello everyone and welcome to our webinar on breaking Jenkins to build it better. I'm Nandini Bharadwaj, the operating officer at CWL, and I'm excited to have you all here with us today. So let's get started. So before we start, let me tell you a bit about us. CWL is a leading cybersecurity infosec company offering comprehensive solution to help individuals and organizations to develop essential cybersecurity skills. Our offering includes the Learning Management System. It provides enroll user with course study material, includes HD video and PDF for a wide range of cybersecurity courses. Number second is CWL Cybersecurity Playground, that is CCSP platform. It offers a theme-based labs designed to simulate real-world scenarios. User can start the labs at their convenience, providing flexible hands-on practice. And number third is Infinity Learning Platform. It's a plug-and-play platform offering immersive learning experience with challenges across red, blue, and cloud security domain. CWL also support customized on-site training requests and accept bulk order for corporate training needs. For more information or to place an inquiry, you can contact us at support@cyberwarfare.live. And dear participants, as promised, we are excited to share that you will receive your attendance certificate and video recording with the PDF material of the webinar. Thank you for being part of this engaging session. We will look forward for your continuous participation. So without further ado, I would like Enoch to take over and let's get started.
So, hi everyone, welcome to this webinar. And let me just, okay. So, today's topic is going to be based on Jenkins. So, if you might have heard, Jenkins was quite a popular tool, and it is also quite popular. We'll be looking at, the security aspect of Jenkins. So about me, I am a security intern at CW Labs, and I'm excited to be taking this webinar today. So we'll cover a couple of things. Let's go through each one of them briefly. And first, we'll have a brief introduction about Jenkins, what it is, what it does, and its uses. And then we will look at common flaws and security flaws and vulnerabilities in Jenkins. And third, we'll see some demos. We'll see a few demos, scenarios where misconfiguring Jenkins can result in security flaws. And fourth, we'll have a look over Jenkins best practices, the configurations and things to keep in mind when working with Jenkins. And fifth, we'll have a few checklists to ensure that your Jenkins is safe and it is um, not exploited by attackers. And then we will have a conclusion and a Q&A session. So let's get right into it. So Jenkins. So Jenkins is a Java-based program. It was quite popular before, and its main um, use was to automate CI/CD pipelines. So if you're not familiar with CI/CD, let me explain to you in brief. So CI/CD basically automates the process of continuous integration, continuous development. It helps developers ship the code faster and deploy faster. So you can refer to this image here. Once the code is committed, the CI/CD pipeline automates the testing, building, and deployment of the artifact or the application. So it was quite popular among development, and it is also quite popular now. Um, some people might think that Jenkins is dead and it's not used at all, but that is not true. People do use Jenkins, and there are a lot of legacy systems that uses Jenkins. And as the entire uh, CI/CD pipeline is based on Jenkins, so it is still maintained, and also it's everywhere. If you just look at the stats, Jenkins is still in use, and people use Jenkins most of the time, and it's also easy to learn, and it's not quite hard. It's not hard at all. You can just learn it in a day or something. So that is why it's quite popular. And why should you care about Jenkins security? So let's say you're writing code and you're deploying it, right? So if your Jenkins is not secured, if in case your Jenkins CI/CD pipeline is exposed, your code base, first of all, your code base can be, visible to people and to unauthorized people, and that is a bad thing. And also, if you have any, credentials like API keys or AWS username, password, and stuff, it will be visible to any user who has access to your Jenkins. And also, in some cases, if your Jenkins system is not properly authenticated, people can actually run jobs, or they can and take down the entire production and make changes to it. And also, finally, there are a lot of things that can go wrong with Jenkins. If it's not, it is quite easy to configure something, misconfigure something that will leave your Jenkins vulnerable. Now let's look at some common flaws and vulnerabilities in Jenkins, which we can see in the wild. So first of all, the most common one I have seen is Jenkins instances just left open without authentication. So in that case, anyone can view the build, the code, and how the CI/CD process is taking place. They can view all these things. And also, if uh, you use some Google Docs, and search for Jenkins, you can find a lot of Jenkins open without any authentication, and you can actually look at the builds and look at the how the CI/CD pipeline is working. So that is also present widely. And one more reason is that since Jenkins is being run on local private network, developers might think that our network is secure and nobody would be able to access our network, and then they just leave the Jenkins instance without any authentication. As you can see here in the screenshot, there is login and the sign up button here, and without anything, if the attacker or anyone has the URL, or let's say if they intrude to your network or get into a network, they can just perform an nmap scan, and they can find the port which Jenkins is running on, and they can look at the views. They can go through all your pipeline and all your credentials and build history and manage it if it is not properly secure. So this still happens. If you perform some Google Docs, you will find a lot of Jenkins instances, like in similar way. And another most common security misconfiguration is that a lot of plugins are being used. So Jenkins has this functionality where you can extend this Jenkins functionality by installing plugins. So plugins give you more flexibility and more control over your Jenkins application or server. So if you're not careful on the type of plugins you're using, there are chances that any outdated plugins are there in a system. Attackers can take advantage of that, leverage it, and exploit, and take advantage of this vulnerability and exploit your Jenkins system. And also installing plugins from untrusted sources. So you can install Jenkins plugins in a few different ways. You can install it right from their managed uh, plugin repository, or you can provide the plugin files um, for Jenkins to run it. So if you're not sure, if you do not trust the developer, you should not be using those plugins. Always be careful what type of plugins you're using, as they can be malicious, and if malicious plugin can do anything if there's a severe vulnerability or any backdoors in the plugins, it can take control of your Jenkins. And also there are plugins which were made, which were used in the past, like the script security plugin. So there's a plugin called permissive script security plugin, which allows anyone can run any scripts in the Jenkins console without the need for administrative privileges. So um, if that plugin is installed, it can bypass any admin restrictions and run scripts without any permissions. So that also, those plugins should be avoided at all cost. and also secrets in plain text. So Jenkins pipeline, you can write pipelines inside Jenkins. So most people, for the sake of ease, there is hard code credentials like your AWS keys or API tokens or passwords or Docker credentials in the Jenkins pipeline. So even that leaves your Jenkins system vulnerable. Let's say you have your GitHub pat token written, I mean, hard coded in your Jenkins pipeline. So anyone who has the pat token, they can actually, if your repository is private, they can use those pat token and view your code and go through your files. So even that can happen for Docker also or AWS keys also. That is quite common. So to avoid that, Jenkins provides a credential storage facility. So you can use that to make those credentials accessible through variables, so that it's not explicitly stated in the pipelines. So if you have your credentials in this credential storage feature, in this facility, you cannot view those credentials directly. So it is recommended that you use those storage facilities which are provided by Jenkins. And this is the example I was talking about. So we have a very small demo pipeline here, and this is what I've seen personally. So having usernames and passwords. So let's say you have a website and you're hard coding your username and passwords here. So if an attacker were to look at your pipeline scripts, they can actually see these credentials hard coded. And also the overprivileged admin. So Jenkins allows you to have multiple users and groups, and you can set permissions for them. But there there are some cases where even low privilege users have low access users. I mean, who should not have access, higher privilege access, being given administrative privileges. That that happens in real world, and it can be quite a security flaw, because if 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 a low access user has those permissions, and if they were to get hacked or something, um, their permissions can be leveraged to to take control of the Jenkins pipeline. So we must always make sure that we follow the principle of least privilege. We must never give permissions that are unnecessary to any users. Only the permissions which are necessary and which are required should be given. Otherwise, it can be leveraged to create attack something. Now, this is um, Jenkins has a configuration where you can use metrics based security. So that allows you to specify your your access levels to each user. You can add your users here. You can give them specific access. Let's say we have manage ownership here, and we have jobs. So we can configure who can run the jobs, who can create jobs, or who can configure it. We also have credentials that we will not be allowing anyone to view the credentials. So we can add each user here and give them the specific permissions. So that also helps keep the Jenkins system secure. And another security flaw is running jobs on the master node. So master node is where the Jenkins software is installed. So we can set up multiple nodes. They call slave nodes. So normally, and what is recommended is that you run your jobs on those slave nodes or different nodes apart from your master node. The master node is where the Jenkins software or application is installed. So running jobs on that actually puts your system at risk. If at all an attacker were to gain access to your pipeline, they can mess around with your system, and if there are any credentials or sensitive information, or let's say passwords or something, they can access all that. So it is usually recommended to not run builds or jobs on the master node. We can create specific nodes. We can have containers, we can have Docker containers, or we can have AWS is easy to instances or anything. So it's recommended to use those instead of running it on your system. If you're doing that, that opens more doors for threat actors to take advantage of the system. And they can also in some cases they can also have some create some backdoor to your master system, and that gives them persistent access. So running builds on the master node should be avoided at all cost. Now let's look at some demos here. The first demo we're going to be looking is the unauthenticated dashboards. Like we have talked before, we'll see how we can find unauthenticated dashboards and what are the things that can go wrong. We'll see how we can set it up and try those attack ourselves. And the second one is Groovy script injection. So Jenkins uses a language called Groovy. It is a Java like syntax language, and we can use it to run multiple scripts or pipelines. And also in demo 3, we'll be exploiting the common misconfiguration, which allows users to sign up and any authenticated users have unlimited access. So we'll go through each of these demos and we'll see how we can perform those attacks here. First, first demo. In this, as you can see, if our Jenkins dashboard is left unauthenticated, as you can see in the screenshot, there's a login option here. So there is if you have the URL or if you have the specific port, you can actually navigate to this Jenkins dashboard, and you can see all the builds that are running. You can manage the Jenkins system. You can look at the build histories. You can set up nodes, add your credentials and stuff. So you can actually, if you're running Jenkins, you can actually set it up yourself and try it out to see this for yourself. So in the second demo, the Jenkins provides a specific endpoint called script. It actually allows you to run scripts. It's actually used for debugging and stuff. So if the script directory is, or the endpoint is exposed, attackers can navigate to this script directory and run arbitrary code here. So as you can see, we have written a script here that will store the contents of this credential.xml file, which is the file that contains all the credentials that Jenkins uses. Let's say you have your Docker pat token or username password in the credential storage facility in Jenkins, and all those passwords and tokens or API tokens are all stored inside the credentials XML. So if you have access to this, you can, it is actually encrypted, but if you have access to the script endpoint, you can actually decrypt those credentials and see the values in raw format. Usually security mechanisms are available, but lack of awareness leaves the script directory exposed. So this is also very common. As you can see, we just run the script and we can look at we can see the credentials here. Although they are encrypted, if you have access to this script console, we can run commands to decrypt this password. They can run any command which they want using the Groovy language. So this payload, which this piece of code which you have written, is in Groovy language, and if an attacker gains access to this console, they can write their own malicious Groovy scripts and run those code, and it can leave your system vulnerable. In the third one, we look at a very common misconfiguration. Normally, what developers do is they let anyone sign up to Jenkins dashboard. As you have seen here before, there's an option to log in here, but there's an option in Jenkins which allows you to let users sign up. So it is quite common that developers enable this option, and also pair it with this option called anyone can do anything. So uh, if you have the login, if anyone is logged in, they can actually do anything on the system. So that is a very huge security risk, because allowing anyone to um, do anything on a Jenkins system is actually a bad idea. And this is the this is a register form I was talking about. So once you click on the sign up link, you can actually give your name, username, email, password, and you can be authenticated as a user. And since authenticated users have permissions to do anything, you can actually run commands. You can go through the build. You can change the credentials and all those stuff. So if this is enabled, and if an attacker were to get access to your network, they can actually leverage this and perform malicious activities. Now let's look at some of the Jenkins best practices. So the first best practice is securing the dashboard. You must never allow Jenkins to run over HTTP. And since Jenkins, even if you're running Jenkins on a local system, it is always recommended to use a reverse proxy like Nginx, so that your traffic is encrypted, and that even if someone has access to a network, they cannot see or view the credentials or any uh, data transmitting over the network. And also keeping Jenkins in a private subnet, not letting the public access it. Have your own IP range, and that also minimizes the chances of leaving your system vulnerable. And always, and Jenkins provides authentication mechanisms. We have to enable it. You can use strong signing methods. You can have MFA, and you can also implement additional verifications as per your need. But these three things actually allow you to secure the dashboard, so that if anyone were to have access to your private network, they would not be able to log into Jenkins and see all those pipelines and do malicious things. Now plugins. So plugins, as I mentioned, has a lot more capabilities. They can, if plugins are not verified, and if plugins uh, are has any malicious code, it can actually leave your system at risk. And while also installing plugins, Jenkins warns you of all these security flaws which are known, and due to some complexities they might not be able to fix it. But Jenkins developers team, they actually try hard to warn you about all these plugins. And if you see one, you have to really try to avoid it, and not using these plugins because they are labeled unsafe. Let's look at let's see this Hudson FCP plugin publisher. It is known to have CSR vulnerability, and since it's warning us, we must stay away from this plugin. And also we must make sure to update our plugins regularly. Keeping our plugins outdated also leaves our system vulnerable. So installing only necessary plugins, and keeping your plugins updated is quite important. Now, as I mentioned, secret management. We can, in the pipeline, this is the pipeline script, we can actually give our credentials, we can actually hard code our credentials like AWS keys or tokens. But instead of that, Jenkins provides a credential management system or secret management system. We can use that to create variables for this part, for this credentials, and reference this variable. Now, if you look at in here in this script, we have given variables here. We have not hard coded any of the credentials here. So we have even given the username as a variable, even the password as a variable. And this helps keep your credentials secret. And even if someone gets access to those credentials, it is encrypted. So try to use Jenkins secret management, and also make sure that you're not printing logs in the console. So when your scripts are running, Jenkins has a console where you can see each steps. So if you have credentials and if you're not masking them properly, it can actually show your credentials there. And that is why you should not be printing so many logs. Make sure that you are adding this plus X flag if you do not wish to see detailed debugging steps in your code. So adding this, if you have any credentials, any passwords, or any detailed steps of your pipeline script, it will not show in the logs, and this actually helps keep the information secure. And role-based access control. So Jenkins has very good plugin that you can install, and that provides you with role-based access. So you can create roles like developer or testers, and you can assign them specific access to each of these jobs. So here we have developer. We have given them access to build, create, configure, delete, and read permissions. Other than that, we have not given them any permissions. So this actually allows you to have control over your users. And as always, follow the principle of least privilege, and also audit. If you go to your Jenkins system and if you check for logs, you can see what's happening on system. If you have any security alerts, if you have any outdated plugins, or even if your Jenkins is outdated, if your Jenkins system is outdated, you can actually see those logs in your Jenkins management directory. So you can check there, and even Jenkins provides logs. You can check your suspicious activity, and if anything is happening at all, you can check those. And using plugins, there are a lot of plugins, security plugins, which are focused on scanning your Jenkins environment to see if there's any misconfiguration, and if there is, you can actually use um, the result and fix it yourself. So plugins like Probably's security scanner does a great job in analyzing your Jenkins pipelines and reports if there are any vulnerabilities. And lastly, always keep your Jenkins system upgraded. So you get updates quite quite a few times. So keep it updated. And as Jenkins is also actively exploited in the wild, so try to keep your Jenkins server updated. Now let's look at some of the checklist for the checklist to avoid common security misconfigurations. So the first one is a Jenkins exposed to the internet. You can use tools like Shodan to see if your Jenkins IP address or if your network is exposed over the internet, and if there is, you can actually take steps to fix that. Also check if your Jenkins user interface is left without any authentication. Make sure that you have strict login enabled if you're working in a production environment, or even if you have your own Jenkins for testing, make sure that you have some strong password and authentication mechanisms. And thirdly, make sure that your plugins are up to date. You can go over to manage plugins, and the plugin manager, you can it actually tells you if you have any update or if any plugins are malicious. You can actually use the um, feedback provided there and do the needful. And also check if non-admin users can create jobs or run scripts. As I mentioned, the script directory, and make sure that it is disabled by default. Do not let any users any unauthenticated users access to the script directory. And also make sure that only admins and the privileged users can create jobs. Check for any secrets. Always check your logs. As I mentioned, whenever Jenkins runs a build or performs a task, it has a specific console. So you can actually look at the console and see if any of these specified credentials or environment variables are exposed. You can look at the logs and find out. And if they are being exposed, you can take steps to mitigate that. Make sure that none of your username and passwords are sent in plain text. Always use Jenkins credential management system and use variables to reference them. Are you logging too much? Logging is good, but if you log too much, it might actually throw out some sensitive information. So make sure that you log only what's necessary. As I mentioned, the script directory, it should only be accessible to authenticated users. And make sure that you have not left your script directory open to all. And also make sure that you have strong password. What is the point of having all the security if you're not using good strong passwords? People can just brute force into your Jenkins system and have access to that. So make sure that you have strong password. And here we have, additional learning resources. I have mentioned a few here. So if you find Jenkins interesting, you can set up your own Jenkins lab, try it out. Or if you're if you're already working with Jenkins, you can read this interesting blogs and videos here I've mentioned here. It is actually helpful to understand the security perspective of Jenkins. So these three are very good resources that you can go through. Now we have conclusion. We have gone through quite a lot, and it's time to conclude here. Before that, I wanted to tell you about this anniversary sale we're having at Cyber Warfare Labs. You can get up to 90% off on bundles and courses. So make sure that you check this out. It is the bigger sale, so you can take advantage of it, and get your courses from here. So you can go visit the Cyber Warfare Labs website, and you can check the discounts and claim those discounts here. Now, thank you for making it till the end. I hope you like this session, and if you have any questions, and if you have any if you need any clarifications about today's talk or anything else in general, you can feel free to ask me, and also you can feel free to connect with me on LinkedIn, and I can take your questions from here. So if you have any doubts or questions, you can drop in, and I'll do my best to answer them. I also want to mention that this presentation which I've made here is based on a blog, which is going to be released right after the webinar. So you can, take a look at the blog and you can go through it. So it is actually more detailed than this. So it teaches you how to set up your own Jenkins instance and perform these demos on your own. So please make sure that you visit the blog, and it has more detailed explanation and things I might have missed on the slides. And it will be published on the CW website on the blog section, so you can have it take a look at that and go through that, and it's highly recommended that you go through that. If you have any questions, please feel free to ask anything about Jenkins, or if you want to know anything about that, you can ask it uh, in the question section, and I will be happy to answer your questions. Also, we have pre-enrollment open for for a few courses which are releasing. You can also pre-enroll for that, and while the discount is live, you can pre-enroll for that also. Yeah, the blog is not uploaded right now. It will be done after the webinar, so you can go through that. Any questions about Jenkins? If you want to know anything about that or any um, specific topic, you can ask them. Thank you. I hope you learned something new in this blog, in this short webinar. And please go through the blog. If you have any questions, you can ask. I'll be here for a few more minutes. Um, Thank you for attending. Okay, if there are no questions, I'm ending this webinar here. I hope you like this short webinar, and I'll see you in the next one. Bye.